Chapter 1, Stress, Normal Stress on Foundation. Let's review an interesting example in distribution of normal stress on a foundation of a Washington monument. So in this example, the Washington monument shown in figure stands 555 feet uh, in height and weight almost 182 million pounds. The monument was made from over 36,000 blocks of marbles and granite, and the base of monument is a square of 665.5 inches at each side, and the stone wall at base are 118 inch at its side. So the area at the perimeter which the force side of this pyramid applies the weight force of almost W equal to 182 million pounds exerted over this area. So we want to determine the compressive stress sigma that the foundation exerts over the cross section at the base of the monument, assuming that the stress is uniformly distributed. This is a very interesting problem. Let's have an interesting monument. Let's have a bit of history about this invaluable structure. So the Washington Monument, designed by Robert Mills and eventually completed by Thomas Sessi and U.S. Army Corps engineer, honoring the George Washington at the center of the nation's capital. Mhm. This is a photo of Robert Mills, an architect and engineer in mid 18th century to mid 19th centuries, and completed by start the project by Mills and finished by Thomas uh, Lincoln a bit of later, a few years later. Construction of the Washington Monument began in 1845 by Robert Mills and halted due to some constructional issue and lack of public interest in some part. And later on, Thomas Lincoln undertook the redesign and construction of monument in 1878 and finished it up by 1884. Which Washington Monument was completed with a major improvement in redesign and of foundation, and also including an aluminum apex atop the obelisk by Lincoln Sacy. That's this part, is almost 3 kg mm, aluminum part about 100 years ago. We'll talk about that. So that's a Thomas Sacy. And also this is a Robert Mills, born in Charleston, South California. He get a private education and then attended to College of Charleston and educated by trained by an architect, Irish architect called James Hoban, and then followed his uh, path of working and thinking and construction of the White House in the new capital. It's commissioned for design, and this is the Robert Mills early proposal of Washington monuments, and this is the end product. Mills died in Washington, D.C. in mid 1855. He was buried at the Congressional Cemetery here, and let's have a brief review over this interesting structure. So as you can see here, this is the foundation. So there is a reinforced concrete at the top. There is glued adjustable jack over here and scaffolding itself and tying. And you can see steel cable, pad, brace, and scaffolding itself. If you move top, you can see here the elevators and the stairs, both of them. This is the elevator and this is the stairs. If we move a bit higher, you can see a working deck for workers, and which is a 3 feet space platform, and there are four motorized work deck on each face of the structure. Mhm. If we move higher, at the very top you can see the again we do have adjustable work deck for workers, and that's the apex or the top of the structure. If you have a closer look to the structure itself, you can see the from here to down it's below ground, and there is a blue stone in the foundation, but because it was originally weak, they reinforced them with a concrete midway through the construction. And you can see the rubble masonry, and that's a donated from cities, states, and so forth, which are from different materials such as marble, granite, sandstone, jade, and also wood. Let's move a bit higher for the the marble in here, the stairs which you can see here, and also the walls which again you can observe them here. The walls, marbles, and a more than in the walls more than 36,000 blocks of marble and granite are used, and they are mainly from a Massachusetts and Virginia marbles. Mhm. And at the very top is a observation deck which you can easily see here, the elevator, and at the top is the peak, is a almost 3 kilogram solid pyramid, part of the original lightning protection system made from aluminum, a rare and expensive metal 100 years ago. The model itself is a inspiration from an ancient Egyptian obelisks, which you can see it here. The height of the structure is uh, almost 555.5 feet, and which is 100 almost 70 meters. This is a photo from the time of digging the Washington Monument Foundation. Let's back to our business for solving this interesting problem. So again, the Washington Monument stands 555 feet high, and we want to know what is the stress exerted from weight of a structure to the foundation, mhm, if the normal stress is uniformly distributed. So to solving this problem, we need to have this area, and we do know normal stress is force over area. So that's the force of the structure, mm, in kilopounds, 181,700 kilopounds over. If you subtract the total area minus the mid section area is the part which walls exert the force to the foundation. So that's a 665.5 inches squared minus the central area, which is the subtraction of this amount minus these two. So that's a 600 minus a 2 times 180, which is 360, which remaining is 3.5.5 squared, mhm, which gives us the area of the structure. So If you divided the force by the same amount of structure, you will get a negative, which is a compressive. That's a compressive force applied to the foundation, and that's a almost 500, a 20. Let me make it a bit cleaner. That's a sigma average of almost 520 pound square inches applied to the foundation from the each wall. That's again the area of force applied the perimeter sections. Thank you. We'll solve more problem on stress and strain for chapter 1.